Hey, Justin. No problemo. Just join my Zoom. All right. Let's do a very, very quick review. All right. I keep saying that, but I'm not even starting. All right. So what does A represent? The Y-intercept. Or if it was in the context of like a word problem, this is how much I start with, or my initial amount. Okay, so the Y-intercept / initial amount. What does B represent? Let's just say rate. Let's not say rate of change because we'll think of it as slope, and I don't want us to think of it as slope. I'm about to show you what's right. If my B is greater than 1, what do I know?
It's growth.
Yes, exponential growth. What we're going to learn today is how to look at word problems and write down the B values. And what we're going to learn today is the B value also has something called the R, which is the rate. And what we're going to learn today is for exponential growth, when we figure out the rate, it's 1 plus R. And don't worry, I'm going to expand, but just write 1 plus R. And we actually kind of did this a little last year, so I'll connect it, well, depending on if you remember last year or not. If my B is between 0 and 1, what do I know? Decay. Yep, exponential decay. And if it's exponential decay, then to find out my B value, if it gives me the R, will be 1 minus R. Again, I will explain what the R is in a moment. Okay, but this is review from last class. Now, when we're talking about word problems, f of x, or what does f of x represent? Y. Y usually represents the final amount. Okay, when we're talking about word problems, this usually represents the final amount of something. While x, not always, but usually in these problems represent like time. Okay, for most of these problems, x usually represents like time. All right. So I'm like reading my notes from last year and doing this as we go. So you're gonna take each. Let me see. Is this in the right form? This is the one I printed out for y'all, right? Yeah. Okay. All right. So exponential growth. So R stands for rate. R stands for rate. Okay. R stands for rate. The rate is always going to be given to you as a percentage. So they'll be like, oh, there was a 50% increase or something like that. Okay. Now, what we don't want is just the rate. Rate cannot be used in the exponential form. We have to transform the rate into the B value. Okay, but in order to do that, we have to change rate to a decimal. Does anybody remember how to go from a percent to a decimal? Perfect. Move the decimal 2 points to the left. So if it ever gives you a percentage, just know I got to change this percentage to a decimal. Okay, and that would be moving the decimal 2 places to the left. So if it gave you 25%, for example, this number would actually be R equals 0.25. And again, this will all make more sense in a minute when I give you a word problem to look at. Now, if it gives me a rate a 0.25 or 25% and I transfer that to a decimal, in order to change that to the B value, I have to do a couple things. If it's exponential growth, I'll have to add 1 to the R. So for example, let's just keep using 25%. A times 1 plus 0.25 to the and 1 plus 0.25 is 1.25. So the B value would be 1.25. This will be the B value if it's exponential growth. If it's exponential growth. If it's exponential decay, I would be subtracting 0.25 from 1. So 1 minus 0.25 to the power of x. And that will give me my B value. Y equals A times 0.75 to the power of x. And this would be my B value. So what's the difference from today from what we previously learned is that today you're going to be given percentages, but you can't just use the percent. You have to change that percent into the B value. And so to do that, you change the percent to a decimal. If it's exponential growth, add 1. If it's exponential decay, subtract it from 1. Okay, you learned this last year. Does anybody remember compound interest? Jesse went to the bank and borrowed $500 at a compounded interest rate of 4.5% and paid it back in 5 years. Okay, we did this last year with compound interest. And if you remember the formula for compound interest, it was A equals P times 1 plus R to the power of T. Well, you didn't know that was just an exponential equation, but you didn't know that's what it was called. So you did do this last year. You just didn't know that's what you were doing, honestly. Okay, so let's fill this part in. To go from R to B, so if it gives you the R and you want to get to B, you're going to change R into decimal form and add 1. Okay, so this is what I've said like 3 times. I just want to make sure I reiterate. So, but R, you have to make sure is it in decimal form. You have to make sure it's in decimal form. Now knowing to get the B value, you would add 1 to R. What if it gave you the B value and you want to look for R? How would you go backwards? You would subtract 1. So let's say, bless you, let's say you wanted the R value. Well, to find the R value, you would subtract 1 from B to get your R value. You would subtract 1 from B to get your R value. For exponential decay, to get the B value, if you have R, you would subtract 1 minus R to get your B value. But to go backwards, let's say it gave you the B value and you want the R value. So yeah, this one will be it'll be kind of different because like, let's set this up as a equation. If I wanted to find R from B, let's say I subtract 1 from both sides, that'll give me negative R, B minus 1. Divide by negative, that'll give me R equals negative B plus 1. So you're adding 1, but then the B is negative. So technically you're subtracting B from 1. So here it would be 1 minus B to get your R value. So we're going to refer to this table over and over again today to help solidify this. All right, so let's look at this table. Let's look at this table down here, okay? We want to get the equation for this table. This is about last class, so let's see if we remember from last class. Does the table show me my y-intercept? Was that a yes or no? No, because you don't see when x is 0. I don't know when x is 0, I don't know what y is. Okay. So because I don't know the y-intercept, I'm just going to go figure out what the b value is. So that means I need to figure out what is it multiplying by each time to get to the next thing. I don't know. How do I figure out what it's multiplying by to get to the next y term? Okay, do it. Tell me what it's multiplying by. What is it multiplying by? So if I'm trying to go forward and figure out what it's multiplying by, I would have to work backwards and divide. So like I can divide any of these things to see what it's multiplying by each time. So if you're just sitting there waiting for people to give you the answer, use your calculator, start doing something. Awesome, 1.0275. So it's multiplying by 1.0275 each time to get to my next term. It is important you know how to do this yourself instead of waiting on someone to give us the answer. So we found that out. I did it by doing 143,850 divided by 140,000. So my B value is 1.0275. This is what it's multiplying by to get from one term to the next. So is that exponential growth or exponential decay? Okay, because this is greater than 1, this is exponential growth. So how do I find my A value? Perfect. Well, if I know that each time it's multiplying by 1.0275, that means I have to go backwards one more time to get to 0. So I'm going to divide 140,000 by 1.0275 to get to my next term. Okay, divide it. Don't wait on other people. Use your calculator. So what we're doing is we're dividing 140,000 divided by 1.0275 to figure out what the term was before that. Some horrific number, yes. We'll round that sucker. So 136,253. We're just gonna round it like this. Okay, so here's my A value. Here's my initial amount. Here's my y-intercept. So if this is the A value and this is the B value, can someone tell me what my equation then is for this table? And if you have no clue what we're doing, then you probably should look at the videos from the previous classes. Yeah, I wrote it down. Okay. To the power of x. Perfect. So here's my equation for this exponential table. Here's my equation for this exponential table. Now let's drag in this r value here. If we know this is exponential growth and we have the b value, what did we say up here is we can find, how do we find the r value from the b value? So exponential growth, if we have the B value, you want to get to R value, we subtract 1. Yes. So 1.0275 minus 1 would be 0.0275. And if I want to change that back into a percentage, that would be 2.75%. And this was our R value. So what's new today? This R value is what's new today. And this is what I need us to be able to do. Figure out the A, the B value, and the R value. Those 3 things. Okay? So I need you to pause and ask a question if you don't understand. Or at least the table part. Give me a nod if you understand from the table how to find the B value. Give me a nod if you understand how to find the A value. Okay, so what we're going to do is I'm going to move on to the word problems, but then when it comes to the assignment today, I will help with the tables, okay? So let's look down at this word problem, okay? And I want you to keep in mind earlier what we said the A and the B value represent, okay? The population in Grand Prairie in 1994 was 48,000. Since then, the population has grown at an average of 3.2% each year. Write an equation to model the growth and find the population in year 2015. I think that's when I made this, because obviously this is outdated. Okay, so let's remember. The equation y equals a times b to the power of x, that's what we're looking for. Okay, so I want your brain juices thinking. Oh gosh. Woo! Okay. The population in Grand Prairie in 1994 was 48,000. The population of, say it again, what's it? Perfect, that's the A, that's how much we started with. Okay, that's where we're beginning at, 1994. So 48,000 represents our A. This represents our A. This is our starting amount. The population has grown at a rate, wait, pause. If it's grown, is this exponential decay or exponential growth? Exponential growth. So I know this is exponential growth. And this is important because we got to know what to do with the R value. At an average rate of 3.2%. Because this is a percentage, I know this is not B, this is R, okay? Because it says percent, I know this is the R value. So my R value equals 3.2%. Write an equation to model this growth. Okay, it gave me the R value, so this is not the B value. So if this is the R value, and I know this is exponential growth, how do I take my R value and find the B value? Perfect, 1 plus R, so add 1 to it. But I gotta change this to a decimal. So 3.2%, what is that as a decimal? Yep, move it 2 places to the left. So R equals 0.032. To find the B value, I have to add 1. So my B value would be 1 plus 0.032. So my B value is 1.032. So I have the A, and I have my B value now. So then someone different tell me my equation. Perfect, 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 perfect. So 48,000 times 1.032 to the power of x. Awesome. Now let's answer that question. What would the population be in 2015? So let's figure out first of all what these things mean. The population in Grand Prairie, blah, 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 has grown at a rate of each year. So Y stands for population, X stands for the years. So if it's asking about 2015, what am I going to plug in for X? Don't say 2015. That's not what I'm plugging in. So I started at 1994, but I want to know what 2015, what the population is in 2015. Yes, I need to do the years in between. So 2015 minus 1994. How many years is that? 21. So I need to plug in 21 for X. So I'm looking when X equals 21, what is Y? So use your calculator. Some of you, I need you to wake up. I need you to get to work. This ain't expectation time. I need you to work. I need you to work. Okay, make sure you're using Desmos as your calculator, please. So 48,000 times 1.032 to the power of 21. Does anyone need me to show you how to do that in Desmos? Everyone do it, because I want to make sure you know how to use Desmos on these things. All right, someone who hasn't spoken, what'd you get?
93,000.
Perfect. Awesome. We'll just round this to 93,006. Good. So that's how many people grew for 21 years in Grand Prairie. That's not a true fact. I think I made up all these numbers. But 1994 is when I was born. So I guess that's what I think. I did not live in Grand Prairie, though. Okay. Ask me questions. What do you think?
I was confused at first because I forgot about the X, like square part. I didn't know where to put the 21.
Oh, okay. Okay. But you figured it out?
Yeah.
Awesome. Okay, let's look at another one. Let's look at another one. Let's look at another one. Forever. All right. Make sure you're writing this stuff down, as it will be good and beneficial for you in the future. Okay. Last one. The amount of fertilizer in a landscaping company's warehouses decreases. Well, if it's decreasing, what kind of growth is, or what is this? Exponential growth or decay? Decay. So I know this is exponential decay. At a rate of 3%, because this is a percentage, I know this is talking about the R value. The amount of fertilizer in the warehouse was originally 78,000. Was perfect. This is my A. Cubic yards. What function models the amount of fertilizer in cubic yards left after W weeks? So we already know our A value, 78,000, because that's how much we started with. That's our Y-intercept. Decreases at a rate of 3%. Okay, that's our R value, but I don't want R. I want B. So how do I find B? Okay, so make it a decimal. So 2 places to the left. Okay, hold on. So that'll be 0.03. But since this is exponential decay, this is decay, how will I find my B value? Yep, so 1 minus, to find my B value, 1 minus the R, so 1 minus 0.03. Is that 0.97?
Yep.
All right, 0.97. So my B value is 0.97. And you can always check yourself, because if this is decay, then your B has to be less than 1. So my function, someone who hasn't gone, what would my function be? You're already gone, Noah. Someone who hasn't gone. Speak up. Sophia? Mhm. 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 To the power of x. Awesome. Thank you, Sophia. So then the question says, after 5 weeks, how much fertilizer would be needed in cubic yards? Perfect. So plug in 5 for x and calculate that.
Can you put the decimal or the step after the decimal?
Let's just not do it today. Perfect, perfect, perfect. 66,981. And I just don't feel like putting decimals today. But, you know, obviously if the question asks for round to nearest this or that, you would need to know how to do that.
What if like the question doesn't tell you where to round?
Then it must, and then I'll have to give you answer choices. It can't be a free response then. So just the answer choice that's closest. Okay. All right. Okay, really quickly, and then I'm really done talking, I promise. Well, maybe not, but really quickly, I'm gonna fill in this table real quick just to make sure everyone felt comfortable with doing the table, okay? It's cold.
Yeah.
I don't want to turn it up because it'd be like a hot box in here sometimes.
Come on.
Turn up. Hey, copy it on this table real quick. And let's say this is like an exit ticket, but not really.
It says exit ticket.
Oh, that's funny.
I think it's an exit ticket.
Okay, so what I want you to do is find the equation of this table. If you don't know how to, then you need to really pay attention when I say it in a minute. Do what?
You're right, your tooth.
I know, look at me. What does this mean about me? Forever in it. Hmm? Got it? You got it? You got it? Okay, the first thing we always need to first think about is, does the table show you the Y-intercept? No, because it does not show you when x is 0. So I don't know the Y-intercept. So first, let me find the b value. How would I find the b value? So divide what? Okay, so the b value is the number that you're multiplying by to get to the next number. I don't know what 2 times what equals 5. I mean, I do, but let's say I didn't. Like, I don't know what 2 times what equals 5. So Noah's telling you, because you don't know, you can work backwards. You can do 5 divided by 2. And when you do 5 divided by 2, that gives you 2.5. So you know that you're multiplying by 2.5 each time. And you can check your work. 5 times 2.5 is 12.5. 12.5 times 2.5 is 31.25. So I know my B value is 2.5. Now, someone other than the people who usually answer, how then would I figure out what the y-intercept is? No, you can't say it. If I know it's multiplying by 2.5 every time,
You go back.
there we
by
go.
Doing 2.
Perfect. Go backwards and do 2 divided by 2.5. And that would tell me what this number is right here. So when I do 2 divided by 2.5, oh,
Sorry, 0.8.
Yeah, you messed up the wording.
it's what? It's what?
I just answered and I know the answer.
Wait, it's what?
0.8.
Thank you, 0.8. Okay, I was like, it's what? Okay, 0.8.
0.8, and then if you said you multiply it by
No, you're messing up your wording.
if you multiply it by 2.5, you'll see that it's 2.
Okay, yes. Okay, so you can always check your work by going forward and making sure if you multiply by 2.5, it would give you this number. So the A value is 0.8. So my equation then would be y equals 0.8 times 2.5 to the power of x. Is this exponential growth or exponential decay? Growth or decay? It's growth because my B value is greater than 1. So this is exponential growth. So if I wanted to find the R value, I would do 2.5 minus 1, which will give me 1.5. Okay.